In this video, we're given the value of sine of x to be minus 6 over the square root of 61, and we're also given that x is in quadrant 3 or terminates in quadrant 3, and we're going to find the exact value of the other 5 functions. Now, the fact that the sine of the angle x is negative tells us that the angle terminates in either quadrant 3 or 4. If it's positive, it'd have to be 1 and 2, quadrants 1 and 2. So we're told it's in quadrant 3. And we also know that if you're given a right triangle, ignore the signs for now. The sine of an angle is the opposite over the hypotenuse. We can consider this 6 here, ignoring the sine as the opposite side, and the square root of 61 is the hypotenuse of the right triangle. So it looks something like this if we construct it. The sine of this angle here would be opposite over the hypotenuse, square root of 61. And this is not to scale here. As you can see, this side looks smaller than this, or it is smaller than this one, but it's not to scale. So this is 6 and this is 5. You construct the triangle. And if you were to use your calculator and take the inverse sine of negative 6 over the square root of 61, you would get approximately 50 degrees if you have your calculator set to 2 degrees. So you can consider that as a reference angle. So your angle would look something like this. There's your triangle here, and this would be your angle x here, and this would be the reference angle. And you don't have to know that, but if you calculate it, it'll be about approximately 50 degrees. So then, if I take any point, let's say they say this point right here is the point negative 5, negative 6. So we go 5 units this way, and then down 6 units. And this radius right here, the distance from the origin to that point would be the square root of 61. So now we're given that the sine of x is equal to negative 6 over the square root of 61. So now cosine of x is going to be the x component over this radius r, the distance from the origin to that particular point. So if you have an angle in standard position, which is what this is, the initial side is the positive x-axis, and then it rotates counterclockwise. It's a positive angle, in this case to quadrant 3. And the cosine of the angle, let's look at the sine that was given, but the sine of the angle is the y component, which is negative 6, over the distance to that point, which is your radius. We could form a circle there. So in this case, it's minus 5. Cosine is the x component of that point, minus 5, over the radius. That was, of course, remember, the hypotenuse of the right triangle. We get that. The tangent of the angle is the y over x. Y over x, that's by definition. If you're given any angle in standard position, and you can find any point on the terminal side of that angle, the sine of that angle will always be the x value of that point. The sine of that angle will be the y component over r, where r is the distance from the origin to that particular point. Since we're talking about distance, r is always positive. So it's y over r, in this case minus 6 over the square root of 61. The cosine is always the x over the r. In this case, minus 5 over the square root of 61. The tangent is the y value over the x for that same point. So in this case, it's minus 6 over negative 5. The negatives cancel out, and this is going to be 6 over 5. You can always do that if you have an angle in standard position, and you can locate a point on that terminal side. So we have the sine, we have the cosine, we have the tangent. Now the other ones are just reciprocals of that. So if I know the sine, I know the cosecant. It's just a reciprocal. So this will be the square root of 61 over 6. And I go and put the negative in the numerator. So negative the square root of 61 over 6. For cosine, I know the cosine, so I know the secant. They're reciprocals. So secant of x is equal to the square root of 61 over 5. Put the negative up here. And the cotangent and tangent are reciprocals. So cotangent of x equals the reciprocal here. So this is equal to 5 over 6. Thanks for watching. We'll see you next time.